Hello, in this tutorial I am going to discuss about three periodic properties, which are atomic radius, ionization potential and electron affinity. First, let me discuss atomic radius. By definition, it is the distance between the center of the nucleus to the outermost electron shell. Let us take the case of hydrogen. Hydrogen is one of the simple atoms having one proton at the center and one electron which is having only one shell. So the atomic radius in case of hydrogen is the distance between the nucleus and the outer shell. So the atomic radius is basically a distance. Okay, of course it is very small. Let us take the case of lithium, which is having 3 protons and 4 neutrons in the nucleus, and it has 2 shells. The first shell or inner shell is having 2 electrons, and the outer shell or the second shell is having only 1 electron. So in this case, the atomic radius is the distance between the nucleus and this outer shell. So this is the atomic radius in case of lithium. Now let us take the third example, magnesium, which is having 12 protons and 12 neutrons in its nucleus. As you see, if you look at the nucleus, I have drawn an arrow. I have put 12p plus and 12n. That is the nucleus. Yes, from here you can see the arrow. Yeah. Now it has 3 shells. The first shell is having 2 electrons. The second shell is having 8 electrons. And the outermost shell is having 2 electrons. In this case, the atomic radius is the distance between the nucleus and this outermost shell. So now we got some idea about what an atomic radius will be in case of different types of elements which are having 1 electronic shell, 2 electronic shell or 3 electronic shells. So remember, atomic radius is nothing but a distance. Now let us talk about ionization potential. By definition, it is the energy that is needed, that is to be added to remove 1 electron from the outermost shell of an atom. Energy needed to remove 1 electron from the outermost shell of an atom is called ionization potential. Let us take the case of lithium. Now lithium is having 3 protons and 4 neutrons, and it is having 2 shells. The innermost shell has 2 electrons, outermost shell has 1 electron. So the energy needed to remove 1 electron from the outermost shell to form a lithium ion, positive ion, is the ionization potential of lithium. So when you remove that electron, what you will get? The nucleus will remain the same, and now it will have only 1 shell, which will be the outermost shell now, which will have 2 electrons, and it will have a positive charge. That means it will have 1 electron less. Outermost shell will not exist as the electron is removed. Okay, so this will be a totally new look for lithium. Okay, so this is the ionization potential. Remember, ionization potential is nothing but energy. Now let us talk about electron affinity. By definition, the amount of energy released when an atom in gaseous state accepts an electron to form a negative ion or anion. Let us take the case of fluorine, which is having 9 protons and 10 neutrons in the nucleus, and the first shell is having 2 electrons and the second shell or outermost shell is having 7 electrons. Now when it accepts 1 electron to form a negative fluoride ion, okay, energy is released. So energy is released when a neutral fluorine atom accepts an electron to form a negative fluoride ion, and the amount of energy that is released is the electron affinity of fluorine. So when it accepts the electron, it forms a negative fluoride ion. Now nucleus will still remain the same. The first shell will still have 2 electrons as before. Now the outermost shell will have 1 extra electron, that means now it will have 8 electrons. So this is the electron affinity. Now you got all the 3 definitions by example and diagram.